Welcome back, Lake.
I know, it's just like it was just yesterday, wasn't it, Francique?
Well, we have been live 12 hours a day since Monday, so it feels like, we can't believe we're getting close to the last trade. So carry on. It's 1:30 p.m. here, so on to you guys.
Welcome, Bill.
Welcome. Thank you.
Thank you, Judy. Thank you, Francis. And we've got Lake and Bill. What's up, guys? How are you doing out there? We just did a couple hours of drag racing. Now Lake, you're very familiar with the drag racing world, spending a little time at Total Seal, but we're talking about something a little different right here. You are going to give folks out there the opportunity to not blow their stuff up, which is there a better way to put it than that? This is like the ultimate, an ounce of prevention is worth a pound of cure type solution. Why don't you tell us?
Well, that's what tribology is all about. I mean, anybody that knows me and has been around what we do with the Engine Performance Expo, the Total Seal YouTube channel, and everything else, we're always talking about tribology. In fact, Joe, I'm actually in the tribology lab at Southwest Research Institute down in San Antonio, Texas, right now. And what we're talking about today is oil analysis. And I said that pound, ounce of prevention is worth a pound of cure. You can take almost every medical analogy you can think of and you can apply it to oil analysis because it's a way of knowing what's going on inside your engine without ever having to take your engine apart. I mean, even here, right now, I'm going to grab a sample. Here's a sample of oil we ran today in the test back here, because we're running some tests right now with our good friends Rottler and for Total Seal, where we're taking pieces of a piston ring and rubbing it against the cylinder wall. In fact, can I show a video? Is that okay?
I'm okay with it. Do you know how to do it?
I'm going to share my screen then.
Share your screen, Lee. Is Bill okay?
I'm going to share my screen.
Hey, I've been on a bunch of these calls with Lake, and one of the things I know is he's kind of shy and quiet. So I just sit here to kind of keep it moving.
That slow-mo action right there.
I know.
There you go.
Cool.
You can see the ring rubbing against the cylinder wall. And you see it's in a bath of oil. Isn't this super cool, by the way? I mean, I can't stop watching this. So we can control the speed, we can control the load, we can control the temperature, and we can change all the variables. We can change the surface finish, we can change the chemistry of the oil, we can change the coatings on the rings. It's stupid, fun, cool. All right, I'll stop sharing there for a minute. Okay, so
you really
this is a
need that
sample of oil from that test. I know I'm having way too much fun to call this a job, but we can analyze this oil and know exactly how much that ring and that liner wore because they're both made out of ferrous materials, be iron. So we can look at the iron levels. In fact, we can know if the coating is wearing off that ring because that coating on the ring is chromium nitride, not chrome like a hard bumper, but chromium nitride. So by looking at the used oil, if there's chrome showing up in the oil analysis, then we know that ring is wearing. Now, we're going to know that anyway, because we're going to go put it under an optical microscope, and we're going to look at it, and we're going to have really cool pictures we can show you, everybody, later on. But this is one of the tools we use to do advanced level oil analysis in engine development. In fact, Bill knows this, all the current API additive packages all now include having to pass a test that includes oil analysis. So when they do the wear test on the engines, they're actually looking at the used oil from those engines. And if your oil can't produce wear under a certain threshold, you can't pass the test. So it really, like you said, Joe, it's a way of knowing what's going on in your engine without ever having to take it apart. And especially now with so many racing series that require engines to be sealed, where you have to run multiple races before you can touch them and do anything to them. How do you know what the health of the oil is or health of the engine is? Well, if you know the health of the oil, you can know the health of the engine. It's that simple.
And you can use that information to decide what changes you can make. In other words, That always goes back to, when you talk about horsepower production with an engine. Well, if somebody comes up to you the track, oh, I've been running a 550, I've been doing all this, I want to go lower. And they always want to go way lower, right? They don't want to go one this grade lower. They want to go to this 0 weight, this 5 weight that's making all this power. That oil analysis is going to tell you incrementally as you do this, if it is safe to go to that level, if you're going to get that performance. And coming back to it, it's a blood test. That's really the best way to look at it. It's a blood test for your engine. First thing you do when you go to the doctor, you don't feel well. What do? They pull a sample, right? They look at it and they say, well, you've got this, you've got that. That oil analysis gives us that exact same data to use.
Yeah, you're spot on, Bill, because that's actually the right way to do any kind of changing to your engine, be it from the oil you use. I'll even say this, the fuel you use.
Absolutely.
What a lot of people miss on is that there's a thing called Reid vapor pressure, which is basically how volatile the fuel is. And, because you can be racing the same car in 100-degree weather or in 60-degree weather, it will change how that fuel vaporizes, which will change the fuel dilution. And I'm just going to say right now, 9 times out of 10, when we see a used oil analysis report and we look at those results, if there's high wear, I can almost guarantee you there's going to be high fuel dilution. Fuel dilution is what we see is the most common problem, and you'll never know that if you don't do oil analysis. But
That's
you can
right.
head off that big problem though, right?
Yeah, absolutely. As a matter of fact, I'm not reach down on my desk, pick one up right here. I'm just literally working. We use these every day. And one of the things I'm sure Lake will get into, but I always say is one oil analysis doesn't always tell you everything, but a few starts to give you a trend. And why is that trend important? Well, you build a brand new motor, you break it in, you're going to do an oil analysis. That should be the worst that oil should ever look. Now you're going to run it, you're going to do these things. I tell people, if you're going to put a power adder on, just like you said, maybe you're going to go from race fuel to methanol. If you're going to do any of these things, if you have that oil analysis for maybe 2-3 oil changes, you make that change. Now that next set of oil analysis that comes back, we can use that to tell you if those changes are having an adverse effect, or now all of a sudden you've made this change and you're causing wear, or your fuel dilution numbers are through the roof. But it's exactly that. Fuel dilution it cuts the viscosity. It's that simple. So it's just so important. And one of the things too is, and I know Lake will want to talk about this. I'm going to tee you up on something, but there's a couple of different ways to measure fuel dilution, right? In our world, in our tribology world, there's a couple of different ways. The way that we do it is the most accurate, which would be GC. I just set you up because I know you want to talk about it.
Well, thanks, Bill, because that's the thing. The old days, the way they did it, they basically used flashpoint.
Right.
And flashpoint is better than nothing.
Right. It's like a crackle test for water,
Right. It's like, yeah, did I hear crackle when I throw that on there? Well, there was some water in there because the water boiled. It's the flashpoint test. There's so many variables that can factor in, the type of base oil you're using, the viscosity of the oil you're using. All these things can cloud that picture. Whereas with GC, which is gas chromatography, you're looking at fuel molecules in the oil. It literally separates out the range of molecules that are in the fuel range, because without getting too crazy into chemistry, we live in the hydrocarbon world. Fuel's a hydrocarbon, oil's a hydrocarbon. They have different lengths. So if you sort them out by length, you can tell how much of what you have is there. It's pretty simple, like doing math manipulatives with your kids, short ones and long ones. Well, fuel are the short ones. And then this does that, and you can know exactly how much fuel is in your oil. And like you said, that trend analysis is so important because depending upon the fuel you're using, the type of application, be it, say, a port-injected engine versus maybe a mechanical injection engine, you're going to have a different level of fuel dilution based on that. Now, you want to try to work your tune-up to get that fuel dilution as low as possible, but you want to know what's normal for your engine. Then if there's any deviation from that, whether intended or unintended, now it highlights it and you can see and begin to take action, because what you're doing is you're being proactive by taking used oil samples and then building that trend analysis, then you can be educated about decisions you're making, and you can see, whoa, something happened here I wasn't aware of. And then even if it's something weird, like the fuel you're using or something like that, has some maybe interesting markers in it. Like I was working with a customer this week that does dirt bike stuff, and he just has a high level of potassium in every sample. Everything else in the engine looks great, but he's in an interesting location, and the fuel source that he has, we can only deduce that potassium is coming from the fuel. We can't figure where else it's coming from, but it's consistent. Right. But there's no water and there's no glycol. Yeah. So it's like, this is strange. So that's the great thing about oil analysis. It's not just one point of data, like Bill said. You can begin to paint a picture by looking at several things. The other night, we had a customer looked at his report. He had an old Porsche Boxster, and unfortunately, he has bore scoring in his engine. And I could tell him that by looking at the levels of silicon, the levels of aluminum, and the levels of iron. And I say, this is early stages, but it's starting to happen. Now, the good thing for him is, bore scoring isn't something like it's a fatal disease where it's going to kill the engine in X number of miles. It's going to be bad for the engine. It will eventually cause failure long run, but there's things he can do, like using the driven DT40 or the DI40 actually is what I recommend, because I think the DI40 is the best oil you guys make. That's just my opinion. I may have had something to do with that product, so I may be slightly biased.
Yeah, you might be.
Might be biased. I'll call it out there. But I can say this. We see tons of Porsche engine samples at Speediagnostix all the time. And I look at every single report. Not that I have enough to do with my day job at Total Seal, but, I can spend 30, 40 minutes each night looking at customer reports and giving them data feedback, because we're not a huge company, because the racing market isn't huge. We're not like an ALS or somebody like that, or a Blackstone or a Caterpillar that's processing thousands of samples a day, and we're processing a handful of samples a day. I can still look at them personally, and it doesn't take a lot of my time. And I can give you personalized feedback, like I did that customer, and say, hey, here's what I see is going on. I know there's a problem. And when we look at all those samples day after day, year after year, I can tell you conclusively, the least amount of wear we see in any oil is the driven DI40. Yeah. It just does a fantastic job. And that's because the chemistry for a Porsche engine we're trying to prevent bore scoring, you need to have something that's very shear stable, which it is. It has a high level of moly, around 300 or 400 parts per million, which it does. And then it's able to really withstand the temperatures. It's full synthetic. It checks all the boxes. It's got a good level of ZDP. So it does everything that you need for a Porsche engine to prevent bore scoring, which is why I recommended it. It just so happens to be that Driven is the brand that has that chemistry, but the chemistry is the solution to the problem. And you can know that chemistry when you look at the oil analysis, right? Because Bill, people can say whatever they want to on the label of oil. That doesn't mean that what's in the bottle is the right stuff.
Right. And with an oil analysis, like it's just like you said, if someone comes to us with a problem and they don't have an oil analysis, then we have to say, well, maybe try this or try that. But if we have the oil analysis, it points us exactly in a direction we have to go from a formulation perspective. We can say, well, you've got X problem, X additive maybe needs to be there that isn't, or maybe you need a different viscosity, but that's what I love about it. And I'll even go into it deeper. There's a real reason why I get on here and I push for oil analysis. In the racing industry, you don't see it like other industries. I push because I have a motive. When I start to get all that data back and I start to look at it, it allows me to look at how our products work in the real world, and eventually look at, well, maybe we need to make a change, or maybe there's a certain type of car, a certain type of racing, a certain kind of engine, a certain kind of gearbox, whatever, that really, if we did this based on seeing remember, we're not looking at the new oil, we're looking at the used oil, we're looking at what comes out the other side, then we can say, well, additive levels, viscosities, all that, that's how we make better products. And it's kind of like us, we're not a huge oil company. you know, we can take and go through that data and really use it to our advantage as far as new formulations and things like that too. It's just such a critical tool all the way across the board, you know.
Guys, there's a question in the question section, and I wanted to jump in. Of course, maybe it's on point, but when people are out there, I want to make sure. Recently had an enthusiast, a marine enthusiast, get a test report, not from Speediagnostix, but a test report anyway, with 144 ppm, parts per million, of lead while running VPC12 on the dyno. Any thoughts on if that would be normal after a dozen dyno pulls? And if you need me to repeat that, I will.
No,
ahead,
I'm pretty sure C12 is leaded. So
Yeah.
that's actually a pretty low level of lead for a leaded fuel. That's one thing.
Yeah.
When you're if you're running an octane booster, you're going to see a higher level of manganese show up in the oil, which is fine as long as we know that you're running octane booster. If you have a high level of manganese in your oil and there's no octane booster, then we got to do some investigating. You might have some kind of guide wear, maybe some seed erosion or something's going on, because you shouldn't see manganese in your oil otherwise.
Right.
But lead, depending upon the type of fuel, depending upon the level of fuel dilution, I mean, I've seen some of these crazy, 115 plus octane fuels. It's not uncommon for after a 500-mile or 1,000-mile race event, those things to come back at 1,500, 1,600 parts per million lead in the oil. So 140 something, that's nothing. I wouldn't even worry about that.
We got another one from, go ahead, Bill.
I was gonna say, what's fun about that is, and when you look at these, is lead can come from two places, right? So we could say, all right, there's a bunch of lead in there, maybe that's bearing wear, or maybe it's a race fuel that's leaded. But when you go back, if there's no fuel dilution and only lead and you're running an unleaded fuel, well, that's a bearing issue. But
you can also look at the copper.
And the copper, right?
Because most bearings are going to be, their leaded bearings are going to contain copper as well. So if you have a high level of copper and lead, then you can kind of know, well, that's bearing wear. That's not just the fuel. And you can even see that with a leaded fuel. You can look behind it. If you got a high level of leaded fuel, okay, well, look over at the copper. Look at the tin. What are those doing over there? If those things are getting out of control, you can still see a bearing problem even though you're running leaded fuel.
Correct. You can triangulate on the issue if you have the data, right? The fuel, you can
and that's the whole point.
And that's the whole point. Yep.
Without oil analysis, you have no data. You're just speculating. With oil analysis, you have data. Now you can do science. And I prefer science over speculation any day of the week.
Paul is out there, and Paul wants to know if oil analysis can help find more horsepower.
Yes. Back to what he was saying, Bill's point earlier about viscosity. Go ahead, Bill.
Well, I mean, so obviously we know reciprocating mass. If you're running a really heavy oil, you're running a 50 weight in engine X. Okay, so a 50 weight is going to cause drag, right? The heavier oil, less drag. So, and I'm just trying to do this fast, but to go down. Now, if I run a much thinner oil, there's less drag, right? So I've released the drag. So I've increased horsepower. Okay. Where oil analysis helps is coming back to when I first got into this industry and I came into the racing industry. I was so excited. I'm at a race and this guy came up and he's in a class. He was a Coyote stock, sealed engine. They look for everything they can to get an edge. And this guy came up and he said, yeah, I'm running this 5W20 oil, whatever, but I really want to win in my next race. So I'm going to a different oil. And I said, okay, what are you going to? And he holds up a bottle of Zero. And he was like, I'm going straight to this Zero. And I said, now hold on a second. Hold on. Maybe that's not the best way to go. Why don't we do an oil analysis and baseline what your engine looks like now? Let's come down some of viscosity, see how that looks. Let's not just go from A, to Z. Let's kind of go.
Don't just jump off the cliff.
Yeah, right. Because at the end of the day, and you come back to it with him, he's a kind of a guy that races and he goes to 8 events a year and all that, but durability is also important too. You don't win a race if you've got a connecting rod out the side of your block. So you got to come back to and look at it from using it as a tool to make a change, to make a smart change. And like I said, if we would have,
Bill,
yeah,
on that, not only the viscosity part of it, if you do the oil analysis on your existing oil, you can see what's the friction modifier level. Because
Yeah.
you come back and there's, less than 100 parts per million moly, you're leaving horsepower on the table.
On the table.
If
That's
you
right.
ain't change viscosity,
Yeah.
going into an oil that has more molybdenum in it is going to make more power. If you go from a mineral-based oil to a synthetic oil, you're going to pick up power. And depending upon the level of synthetic in the oil, you can tell all those things by looking at the oil analysis. We can tell how much ester base stock is in the oil by looking at that used oil sample.
Right.
And these are ways you can unlock more power in your engine just by doing oil analysis and establishing a baseline, having data to make decisions from.
That's right.
Okay, guys, let me ask you this, because we are, we're not out of time, but we're getting close. And to me, I'm sold, right? I've heard this bit before, and I think this is a no-brainer. No, but I think it's obviously a no-brainer, and I get excited, the day I put my next engine together. This is something I'm definitely going to do because it just seems to make sense. So let's assume that everybody's on the same page with us. What is the right program here? Like, what should someone do? We are a drag racer, we're a sports car racer, we've got a fresh engine, it's just been off the dyno, and give us a routine. Like what
example right now, take it when you just come off the dyno. Bill mentioned earlier, that's the sample you want that's the most valuable.
Yeah, absolutely. We know that your first oil analysis after break-in is going to be horrible. We know that. It's going to have all kinds of, it's going to tons of wear. We know, we get it. Silicon, everything's going to be all over. But we also have a snapshot of the worst case scenario right there. Now our goal so then you're going to go through break-in, you're going to put X amount of miles. We're going to start trending down. We're going to know. And then all of a sudden, let's say 2 years later, and like I said, you don't always have a tribologist, standing behind you when you look at an oil analysis report. I mean, you're going to get support, but let's say you pull it out and all of a sudden now one of your wear metals is boom up through the roof. Well, you could go back to that first break-in oil sample and look at that and say, well, at break-in, I was here. Now I'm here. You got a problem. You've got a snapshot of the worst case scenario. And that's always why I always suggest that people do a break-in sample.
And how often after that? Like, okay, you've done your break-in. How routine is this?
Well, it really depends upon how mission critical it is. So let's say you're a NASCAR team and you're racing for millions of dollars. Okay, we have customers that are NASCAR teams. They sample after every single race.
Right.
They're willing to pay for that expedited servicing fee so they get the results back in 2 days. So they want to know immediately after the race, what's going on with my engine? When can I use it again? Or do I need to do something about it? So if you're racing for high stakes, you can get information on a weekly basis. If you race every week, have that. If you're just a grassroots racer and maybe you do a few track days a year and all that, well, then, make sure you do it maybe once or twice a year to make sure you have that baseline. You don't have to do it. Or you're just an enthusiast that has a either classic car or a car you love, and maybe you put only about 3,000 or 4,000 miles a year in the car. Well, one, you only need to do one oil change a year anyway.
Right.
Just take the sample with that, and then you can have that yearly health checkup like going to the doctor again and build that trend over time to know what's going on. So the easy answer is, how critical is it to you to have engine durability? If it's going to cost you millions of dollars or tens of thousands of dollars to blow up an engine, then spending $100 on oil samples is really cheap. That's cheap insurance.
Yep.
If you're not racing for money and you're just trying to protect your investment long term, then spending $60, $70 a year on oil analysis is, again, pretty cheap insurance for a long-term investment to do it once a year.
And how much is it for an analysis?
Okay, so the standard turnaround package, which is you get your results back in 6 days from Speediagnostix, that's $70. And then the 3-day ultra-fast turnaround is $120. And they're available from Driven, by the way. You can order Speediagnostix kits. You can order from Driven if you're a Driven customer. You can order from Total Seal now as well. So anybody that's kind of in our network, our family of companies that we all work together and kind of think alike, that we're trying to help racers do the best. We're fortunate between companies like Driven and Total Seal. We've been able to work with the NASCAR teams, the Formula One teams. So we can bring that highest level of technology and bring it down to the mid-level grassroots racers and enthusiasts so they can be as smart about their decision-making as those guys are, because we had mentioned it earlier, but every Formula One team does oil analysis at the racetrack.
On site.
There's people like me and Bill at the racetrack doing analysis every single race, every day of the race weekend.
Makes sense. Makes sense.
Yeah.
Where and how to get in on this? You mentioned Driven, you mentioned Total Seal, but the prime directive for people out there who say, hey, I want to do this, I want to connect, at very least learn more. Lake, where should they go?
If you want to learn more, just go to speediagnostix.com. Now, it's spelled really weird. It's SPEEDIAGNOSTIX. So there's only one D and there's an X at the end. So speediagnostix.com. Make sure you check out our YouTube channel. We post videos on there. We do stuff. We like doing videos. So there's lots of stuff out there.
And we pushed Speed Diagnostics products back on the homepage of the EPA Trade platform. So go right there and click and connect with Lake. So Lake, Bill, thank you so much for being with us today.
Registering on EPA Trade is easy. To start, click on the Join for Free button on the homepage. First, search your company to see if it's already in our database. If you see your company on the list, click on it to select it. Then, choose Claim Company if you are one of the decision makers, an owner, marketing person, or main company contact. Or choose Join Company if you are an employee, and press Continue. If you couldn't find your company in our database, select Register a New Company. On the following page, fill out your name, email, phone number, job title, and choose a secure password. If you chose Register a New Company, you'll need to choose your business type. Select Supplier if you're looking to display products or services and connect with buyers. Choose Racing Business if you're looking to source new parts and connect with suppliers. Choose Race Team if you own or are a member of a professional race team. Then, enter your company name. Please provide a website, Facebook page, or LinkedIn if you have one, and choose to either claim or join the company. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Finally, click Register Now and your registration will be submitted for approval. An email will be sent to your inbox. Please confirm your email address and you will be approved shortly. Welcome to EPA Trade.